Hello and welcome to my other presentation of data visualization. This time around we are using a dataset that was got from a research about water quality in selected regions in Uganda. This research was published on 5th of May 2023, and the objective of the research was to ascertain the extent of contamination in various water sources in the selected districts. Now, the districts that were selected were 16 in number, and they were emanating from Central Region, from Eastern Region, Western Region, and Northern Region of Uganda. Water samples that were detected springs, shallow wells, taps, and boreholes. And immediately, these samples, when they were picked, they were transported on ice to the laboratory for analysis. Now, I would like to just briefly show you the data set that we're talking about. So when you sit down here, these are the districts that were considered, and each tab has the data collected for that district, and the data collected includes the elements of the water that they considered, includes the water source. Here you see there's a shallow well, there's a borehole, there's an open well, and so on and so forth. Uh, and our visualization is basically going to summarize key aspects that I picked for this particular uh, presentation. So the first one that we want to look at, first of all, it's important to note that they used there were about four elements of contaminants, okay, things that were considered to be contaminants of water. Uh, they used nitrate, they used E. coli, they used iron, and they used the turbidity levels. Turbidity is basically the relative clarity of a liquid, or in this case of water. How clear is the water? The water can be dirty, it can be what, and so many things that can cause that, like silt, like mud, like algae, like plant pieces, like wood ashes, and so on and so forth. So uh, now, if the water is dirty, then it's considered contaminated. So that is the measure of turbidity that we are going to look at here. So for starters, the ratio of non-contaminated sources per region. So meaning, if you look at the orange color, those are the sources, the proportion contaminated, and the blue color proportion not contaminated. So in the north, this was the only portion that was contaminated, and the rest were normal or not contaminated. In the east, you'll find that the level of water sources contaminated was the proportion of water sources that were contaminated was more than those that are not contaminated. When you look at the west, there's the same story. The ones which are contaminated are more than the ones not contaminated. And when you look at central, it's the other way around. The ones which are not contaminated were more than the ones which are contaminated. So this at a glance you'll be able to analyze that kind of information. So our next visual is about the highest contamination value per region. So you find that North had the highest contamination value for turbidity. In other words, I think they found that so many sources of water in the northern part are dirty, or they are dirtied, followed closely by western, followed by central and eastern region. So for the contamination of nitrate, we find that central had the highest, closely followed by eastern, and then northern, and then western. So for E. coli, you find that I think Western had the highest, followed by Central, followed by Eastern, and Northern didn't have any particle contaminated by uh, E. coli. And then for iron, you find that same story. Northern didn't have any water source contaminated by iron. Neither was Western, but Eastern and Central they had, and there were not even so many of them. So this visual will help us to analyze that piece of information. So when you look at the next visual, that is a scatter plot of contaminated sources per region. So you'll find that in this scatter plot, uh, each of the dots is representing a district, the 16 districts that we have in the data set. And you find that has uh, each district has color code. Okay, each region has a color code. You find that blue is for north, blue is this one here, is the for the northern region, green is for the western region, yellow is for eastern, and red is for central. Now, uh, this number here shows how many uh, sources are contaminated, how many sources in that district are contaminated. So you find that for blue, which is north, it had only like one source that was contaminated. That's why it's down here. Now for western, it had 13. 13 were contaminated, and the rest were okay. Now for eastern, uh, some this one. These are the various districts, and this district had like 12 district. This district had like 11. This district had like 10, and so on and so forth. And then for central, it's the same story. So these dots show this part here shows the number of uh, of sources that were contaminated, or the number of water sources that were contaminated per district. So you find that some districts didn't have any water source contaminated. That's why they are zero here, while others had few and so on. So the scatter plot will represent to us that at a glance. Then this next visual shows the number of sources affected per contaminant. So you find that turbidity had three, three water sources affected by turbidity. For nitrate, you'll find that there were 18 water sources affected. This is in general. In general, all the water sources, if you if you bring them together. Then E. coli had like 25 water sources affected, and iron had like 7 water sources affected. So this graph will help us, comes in handy to represent to us the effect of these contaminants, basing on the research made. So this pie chart also shows the distribution of the water contaminants. You find majority of the water sources were normal. In other words, they didn't find any of these contaminants in them. But however, the green one shows the proportion of E. coli. The gray one shows the proportion of nitrate. The red one shows the proportion of iron, and the yellow one shows the proportion of turbidity. And you'll find that it's more similar to what you see here. E. coli, nitro, iron. When you look at this one and this one, you will see that they are more or less similar in terms of proportion. So there you go. Now, finally, this is our last graph, and here we are showing you the contamination ratio per water source. In other words, these are the various water sources that we have that were sampled, And now if you see the blue shows that the water source is contaminated, and the gray shows that shows the proportion of water source that is not contaminated. So in the hand dug well, of all the hand dug wells that were sampled, all of them were contaminated. Rain tank, of all the rain tanks that were sampled, all of them were contaminated. Renzori water bottle, kiosk had 50-50. Then water supply system, none of them was contaminated. Reservoir, none of them was contaminated. P2P, only a small portion was contaminated. Tap, borehole, spring, and so on and so forth. All this donut graph shows you uh, a snapshot of the contamination ratio per water source. So this is briefly what I had in relation to this data set. This visualization was powered by 3D.js. That's the tool I'm using this time around. So I can show you some of the codes that I had. This one I was calling the data that you are seeing. I uploaded it in GitHub and I put it there. Scatter plot also had the same. Pie chart had the same. So this is all 3D .js code. So I want to thank you all for viewing, and I wish you the best of the day. Thank you very much.